cars. Peanut butter in jars, laundry dryers, home security systems, super soakers and suspenders. I could go on listing many contributions across institutions. Supreme Court and bulk court, it's been an evolution. And we sing it every day. Blue notes like Harold Melvin for this Billie Holiday. We know what's going on thanks to Marvin Gaye. Get a bounce in our step on cue like Kid and Play. Gwendolyn and Kendrick, our poets represent. Hold mics tight like truths that's self-evident. Yeah, we know our heroes fantastic, but gotta remember the forgotten on the Atlantic. We gotta honor our departed, taken from the land where humanity started. Left to the right, top to the floor. When I say Black history, say it's yours. Black history, it's yours. Black history, yes, it's yours.
Really? Which makes a
Good morning, everyone. We're going to go ahead and get started. We have a lot to cover today, and I just want to make sure that we can get it all in. We're going to have so much fun, and I'm excited about Space Day. We are RTP NSBE Jr, which stands for Research Triangle Proteges Chapter in NSBE Jr. And we're going to have a couple of guests coming before us. But before we get started, I want to just kind of give everybody the flow of things. If you have a question that you want to ask, you can put that in the chat, and I will get my officers to help, get our NSBE Jr officers to help with, monitoring the chat. If you're interested in joining the chapter or any other chapters, we invited several chapters here today. You can do that as well. So we may have the Winston-Salem chapter joining, and we may have some chapters from other parts of the United States stepping in as well. We're all virtual, so you can join our chapter too if you like. It doesn't matter where you live at right now. So with that, I'm going to go ahead and get things kicked off. And I know it is a Saturday morning, and it's you all could have been doing a lot of different things, but it is much appreciated to be able to join us and as we celebrate Black History Month, as well as learn so much about space. So let me get my PowerPoint going here and we'll get going. All right, so we're going to learn about Earth, inner space, outer space, and aerospace. And we have a tutoring session that's going to kick off after the event. We'll probably have some time for a little bit of a break there, but we have been focusing on tutoring this year as a result of just students needing to kind of get back on track with so many things that have happened with between virtual school and on-site and kind of hybrid formats. So we wanted to get that going, and we will have some time for that later today. So welcome everybody. If you have any questions, like I said, feel free to pop those in the chat. And we are excited that you have come to celebrate Black History Month as well as Space Day. RTP NSBE Jr was launched in October 2019. It is for K through 12. If you're interested in joining, the membership dues are $12 for grades 3 to 12. If you are in K through 2, second grade, it's only $5. You only pay the local dues. Officially, NSBE Jr starts at the 3rd grade, but we like for students to get involved earlier, so it's a smoother transition for them when they do get older. We are a community chapter. We are sponsored by RTP NSBE, which is a professional chapter that's adults. And we have programs that include STEM enrichment, and at some point we will have some hands-on engagement again. But at this time, I'm going to ask our president of NSBE Jr, Jairus, if he could read our NSBE mission and lead us in that.
NSBE's mission is increase the number of culturally responsible Black engineers who excel academically, succeed professionally, and positively impact the community.
Thank you, Jairus. And NSBE does not discriminate. Anyone who connects with this mission, if this mission resonates with you, you are welcome to join, to volunteer, and participate. And just briefly, I won't be able to take the time to go through all of this information, but I just wanted to highlight a few African Americans in space. And then when we have our breakouts, we will have some time if people want to come back and peruse this a little bit more in depth. But just kind of wanted to set the tone as we are looking at space, and this is Space Day. We have a number of African Americans, but just a few that were iconic in certain ways I wanted to bring attention to. Dr. Mae Jemison is the first African American female in space, as you see there on the left. And the picture beside her is Dr. Ronald E. McNair, who unfortunately we lost him in the Challenger space shuttle explosion. He is the second African American in space. Guy Bluford in the middle is the first African American in space, and Fred Gregory was also in the same African American, same NASA program as Guy Bluford and Ronald McNair. And then at the bottom, does anybody know who these ladies are? Any guesses? You can just come on.
I know they're from the movie Hidden Figures.
The Hidden Figures, and that's exactly right. There are a number of women who are considered Hidden Figures, but they were they were actually the first group in the 60s. Anybody recognize any of them or know any of their names?
I remember some of them. Me?
I can faintly hear someone saying it.
Katherine Johnson.
Katherine Johnson is one. Yep, this is her on the right.
Dorothy.
Yep.
Dorothy Vaughn
Dorothy Vaughn is in the middle. You guys have been doing some homework.
and Mary Jackson.
Excellent. Excellent. Whoever that is, please put your name in the chat and say, I knew who the Hidden Figures were, and I may have something special for you. Okay. All right. So something else you may not know about was, before people actually get to, an achievement, someone has already paved the way. So this is Captain Ed Dwight. He was actually the first African-American astronaut candidate. However, he was not able to finish the astronaut training program. He was a fighter pilot who nearly became the first African-American astronaut. He actually would have been one of the first American astronauts as well, not just African-American astronaut. He was on track for this. President Kennedy wanted him to be in the program and had selected him, but due to some challenges during that time, this is in the 60s. So if you know the history, that was racism, and people were not understanding differences and how that discrimination was affecting people. He was not able to fulfill that dream, and especially after President Kennedy got assassinated, he did not continue. He basically resigned from the military because he was in the military, and he ended up resigning. But he was in Ebony magazine, and he had been publicized. And this is a picture from Ebony magazine. You probably don't even know what a magazine is, but this was a book that used to come out every month growing up, and every Black family had this book because it had a lot of our history. We didn't have the internet, so basically that's how we got a lot of information about what was going on in Black culture. But anyway, he was pictured in that. He did not get to enter into the space program, but he would have been the first African-American astronaut, and he would have been one of the first American astronauts too. He would have been on the same flight that the Hidden Figures worked on. So a few years later, I think it might have been about 5 or 6 years later, Major Robert Lawrence actually came along. He is actually the first African-American astronaut. He actually was in the NASA program. However, he was killed in a test flight in the military. So he would have been in it. Unfortunately, he was killed, so he did not actually get to go into space, but he actually was an astronaut. He did not get to go into space, but he was actually the first African-American astronaut. His name is Major Robert Lawrence. So these are people that you may not have heard about. We will distribute this information. So all of these links here will give you videos and other information about them. And then, of course, as I mentioned earlier, Guy Bluford, he was the first African-American astronaut. He went into space in 1983. And then I won't go into all of this, but we've touched on this before. Ronald McNair was on the Challenger Space Shuttle, which actually exploded January 28th, 1986. Some of you may have been watching that. I was watching that in high school and actually had a chance to meet him when he visited my high school. And when I was in the 10th grade, I actually had a chance to talk to him about what I wanted to study. He went to North Carolina A&T State University. He was a physicist, also a very well versed saxophonist. And he also, got his doctorate at MIT in physics. And the engineering building at North Carolina A&T State University is named after him. Unfortunately, all of these people on the screen perished when the shuttle exploded. And after watching that, I became very inspired. Unfortunately, it was a bad thing, but it kind of made me have more purpose in why I should consider engineering. He and I had talked about whether I should do engineering or music. And he's like, he was like, why don't you just do both of them? All right, so let's talk a little bit about outer space and aerospace. And I have talked with some of you, and I know that you may have had some interest in this area, but there is a resurgence of interest in space. And there's companies outside of NASA now. You can work for SpaceX or Blue Origin. There's other places where you can work, and there's other ones, I'm sure, in the aerospace industry. So aerospace and aeronautics and space travel, these are areas where the jobs you see listed, these job titles or types of work is what you could do if you worked in this industry. And we do have coming up here shortly a representative from the Rocketry Club at NC State, and he is in the aerospace engineering program there, and he can probably give us a lot more information about his experience and what he plans to do. So aerospace engineering is the primary field. There is a difference between aerospace and aeronautics. Aerospace is more connected with developing an aircraft or spacecraft, where aeronautics is more on the flight technology and advancements of vehicles getting into outer space. So there's a lot of information about space. We could actually talk about it all day long because there's so much information. It was really hard trying to decide what we should include and not include, but I will not belabor the topic. And I'm gonna ask Michael if he would like to go on and come on camera, and I'm gonna stop sharing and let him tell a little bit about himself and the Rocketry Club, and he's gonna give us our first activity today. You there, Michael?
Yep, I'm here.
Awesome.
Am I able to share my screen?
You should be. Hold on, let me make sure. You try it now. So Michael, first tell us a little bit about you and how you got interested in aerospace engineering.
Yeah, and so like Dr. Arnold McFarland said, my name is Mike, and I am an aerospace engineering junior at NC State University. And I'm also joined by my friend Francis, who is also an aerospace engineering student and in the high-powered rocketry club. And so I kind of got into aerospace engineering when I started building a lot of smaller model rockets when I was younger in like middle school. And that is actually a project one of my 6th grade teachers had us do. And so ever since then, I always just really liked building these rockets. And so as I started getting into high school and things, I got more into the actual engineering side of it. And that's really what made me want to go into aerospace engineering and study this for what I actually want to do.
Okay, can we ask Frances to tell us a little bit about herself too and how she got interested?
Can everybody hear me okay?
Yes.
Sometimes I have a little trouble with this microphone. I'm Frances. As Mike said, I'm also an aerospace engineering student that's in the high-powered rocketry club. And I actually grew up around Houston, Texas, and some of you may know that's where NASA Johnson Space Center is.
Yep.
So I kind of grew up entrenched in that sort of space attitude that the whole area has. I was lucky enough to go visit the Space Center one time and see some of the work that they were doing. And it was just insanely cool. And I decided from that point on, I was in high school, I decided, you know, this is what I want to do. I want to build these things. I want to send people and things into space. And so far, that's what I've been trying to do.
Wonderful. Excellent. All right. Anybody have any quick questions for Francis or Michael? All right. If you do, just put them in the chat. So Michael, you can go ahead and proceed. Thank you.
Yeah, and so we kind of already touched on it a little bit, but kind of who we are as a club is that we are just a collection of students at NC State, and really what brings us all together is that we all really like rockets. And so most of us are in engineering, but we've also had members in our club from environmental science and zoology and other majors. And so, you know, to like rocketry and really be in our club, you don't have to be an engineer. And then kind of what we do as a club is we build rockets to compete in the NASA student launch competition. And so every year, NASA will give us a challenge and a set of requirements, and we have to build both a rocket and a payload to accomplish that challenge. And so, for example, this year, our rocket has to go somewhere between 3,000 and 6,000 feet, and our payload is to be able to take measurements and determine where our rocket lands without using a GPS. And so every year we get a challenge like this that is intended to sort of model a real life mission NASA would do. And then we take our 2 semesters to solve the challenge. And so to kind of give an example of what some of our rockets look like, we do have a couple of videos where this one is of that rocket you see on the left, and it's actually taken as a slow motion video. And then this one is a cool video because it was actually taken from a camera that was on board the rocket. And so as it launches here, you see as it's going up, the rocket has a lot of spin, but you can really see how high in the air it's going and really get a sense of what the rocket sees as it's flying up in the air. And this is one of the videos that I think is really interesting, just because as we're watching these rockets from the ground, we're standing a good bit away from them because we need to be so that we're at a safe distance in case something goes wrong. And so by the time the rocket gets up to this height, it's just this tiny dot up in the sky and we can't really see it. And so having this video really gives a unique perspective as to what the rocket really sees as it's flying up in the air. And so you can see when it was going up, it was a pretty stable video. But now once it's under the parachute, there's a lot of movement as the different sections of the rocket are kind of swinging around and then eventually hit the ground. And so then with that example, Francis is going to go ahead and talk a little bit more about kind of what goes into how we actually design and build our rockets.
Right. So first off, if anybody has any questions, feel free to pop them in the chat or unmute yourselves and we'll be happy to answer anything. But so we start off the year with a subscale rocket. NASA wants us to build 2 rockets for the competition, a subscale and a full scale. And the subscale kind of shows NASA, hey, this is what we can do. We can put together a rocket and we can launch it. Isn't that wonderful? But before we do the subscale, how long does it take to build it? Depending on when we get all of our parts and what we're putting on the rocket, it can take anywhere from, I want to say, like 3 weeks to maybe 6 weeks to put it all together. And I'll talk about assembly a little bit later because we've got some really cool things that we do to put everything together. But we start off with a computer model of the rocket. And this computer model helps us think about how our rocket is going to perform, how high it's going to go, what the aerodynamic forces are on the rocket. And then we use that information to put together our subscale. Once we launch our subscale, we then start building our full scale rocket. And that's when we can actually start putting things on the rocket, which is really fun. How high does it go? They kind of vary in how high they go. Our competition used to say we had to hit a mile above ground level, or AGL. But now we get to declare our altitude, or sometimes also referred to as apogee. And I think ours is going about 4,500 feet above ground level, usually around that. So what goes into designing a rocket? We have to consider a lot of things for our specific competition needs. We have to consider, like you asked, our target altitude. What do we want it to be? So that will also have to take into account the weight of the rocket, because less weight means more going up. The material also influences the strength. So if we know that our rocket's going to hit the ground in a weird way, or it's going to probably land in a kind of a wet place, we want to take that into consideration. And we also have to think about the thrust that's going into our rocket. So the motor, what kind of motor do we want to use for the specific altitude that we have picked? And the structures portion of assembling and designing the rocket is where the physical structures of the launch vehicle is designed. We have to think about the diameter of our rocket, so how big it is, how kind of thick it is. And then a bulkhead is anything that separates one section of the rocket from another. You can see in the bottom right, that's a computer simulation of a bulkhead. I think that's, yeah, that is called a stress test. And it allows us to see how much stress or force we can put on these different components before they eventually break. We have to consider what these things are made out of, because that influences how quickly or likely they are to break. And here's a fun little video of the bulkheads that I was talking about being laser cut. Now, a laser cutter takes any material, for our purposes usually wood, and shoots a laser right through it. So it cuts it really nicely and evenly. And then once we have all of these layers of wood, we pop them out and put layers of epoxy. And epoxy is kind of like a really strong glue that dries to a crunchy solid, and it's not going anywhere. So we layer them one on top of the other to create a really thick and a really strong bulkhead that can separate the different components of our rocket. And on the right, you can see the left two pictures are called layups. That's when the epoxy sits there and dries. And on the right is, that's a fin can, right, Mike? Yeah, that's a fin can.
Yeah, that is where Alex and I had to take it down to the machine shop to cut the slots in the fin can.
Oh goodness, and those slots are where our fins go. And I'll talk about fins in just a second. And how do we make the rocket streamlined? If you throw a basketball into the air versus if you throw a paper airplane into the air, that paper airplane is probably going to go a lot farther if you apply the same force to it, because it's more aerodynamic, meaning it has more lift force pushing it up from the air and less drag force slowing it down from the air. Things that influence this are the nose cone size and shape. The nose cone is the tip of the rocket, so how that's shaped. The fin size and shape and the number of fins there are. The fins are those little almost triangular looking things at the bottom of the rocket. The motor selection, because the motors can have varying amounts of thrust in time. We also have to make sure that the rocket doesn't wibble wobble too much and that it's stable. And so on the right, you can see the different types of nose cones that we can use. And these shapes of nose cone are all great for different speeds. We go below the sound barrier. If any of you know what the speed of sound is, that usually constrains our design a little bit. And on the left, you can see a bunch of different fin designs. We usually use a clipped delta. And right now we're using 4 fins. And it all depends on how high we want to go and what the stability of our rocket is going to be.
Yeah, and so with that, I know a lot of the things we kind of work on both as a club and in our classes at NC State can seem really complicated, but there are simple ways to kind of understand these things and, simple activities that you can kind of do at home to demonstrate them. And one example of this that we come up with is demonstrating how airplanes are controlled using just paper airplanes. And so we made a short little video here that both kind of explains what forces airplanes experience, as well as how airplanes are controlled. And then we give you an activity that you can do at home and play around with to really demonstrate how these airplanes work. And so with that, we can watch this short little video and kind of go on a little bit about some activities you can do at home to really get involved with aerospace. Today we are going to be discussing the forces an airplane experiences during flight, as well as how to control an airplane. These forces are fundamental to all flying vehicles and provide the foundation for how aircraft are able to fly. The first force we must consider is lift. Lift is the upward force generated by the wings. Lift is offset by the next force, the weight of the aircraft. The difference between these forces determines how high in the air the plane stays. If lift is greater than weight, the plane rises. However, if lift is less than weight, the plane will fall. The next force to consider is drag. Drag is caused by friction between the plane and the air molecules and acts to slow the plane down. Drag is offset by the final force, thrust. Thrust is the force created by the engines which pushes the plane forward. These 4 forces represent a simplified version of what happens during flight. Now that we understand the forces that contribute to flight, let's take a look at how aircraft are controlled. We change the direction in which planes fly using what are called control surfaces. These are essentially hinged surfaces that are used to redirect the flow of air around the plane. The first control surface we'll talk about is the rudder. The rudder is located on the back section of the plane and allows the plane to turn to the left and the right. If a pilot wants to fly to the right, they will deflect the rudder to the right. And if they want to fly to the left, they will deflect it to the left. The elevators are also located near the back of the plane on a piece called the horizontal tail. The elevators change the pitch of the plane by tipping it up or down. The flaps are located on the wings near the body of the plane. By changing how far the flaps are deflected, a pilot can change both the lift and the drag of the aircraft. The flaps are most commonly used in order to provide more lift on takeoff and landing. Finally, the ailerons are located on the tips of the wing and control how the plane rolls. By deflecting the ailerons in different directions, a pilot can cause the aircraft to tilt to the left or right while still flying straight. By manipulating all of these control surfaces, a pilot is able to maneuver an aircraft in order to achieve stable flight. Additionally, sometimes a pilot will be required to use multiple control surfaces at once. For example, when turning an aircraft, a pilot not only deflects the rudder, but also deflects the ailerons in order to bank into the turn rather than turning sharply. While this may seem complex at first, it is easy to understand with practice. You can do this at home by building paper airplanes and attempting to control the direction in which they fly. Now we will walk through a simple activity that demonstrates the control surfaces of an airplane by building paper airplanes. All you will need for this activity is a sheet of paper and some scissors. By creating a rudder and ailerons, we will be able to control which direction the plane will fly. Throughout the activity, we will make the plane turn to the left and the right, as well as pitching up and down. The first step is to make a simple paper airplane and get it to fly straight. Next, cut a rudder and ailerons into the plane with a pair of scissors. You should be able to bend the paper in different directions in order to manipulate the control surfaces. Then try and get the plane to fly to the right. Next, try and get the plane to fly to the left. Finally, see if you can get the plane to pitch up immediately after throwing it. You can also try and do multiple changes at once to see if you can combine the effects. Hopefully, you've learned about the basic ways in which airplanes are controlled. By changing the control surfaces, you can make a plane fly in any direction that you want. I encourage you to keep trying new things and discover what other full flight patterns you can get your plane to perform.
All
And
right.
so I know we went through that a little fast in the video, but as you can see, if you looked at like a Boeing 737 or any other large commercial aircraft, and you really look out the window while they're flying, you can see there's all these moving parts on the wing that help control it. And so it may seem complicated, but what it really comes down to is if you have your normal paper airplane, you just take a flap and you deflect it either up or down. And by doing that, you're able to change how the air flows over the wing and cause your plane to either roll or pitch up or down. And so that's something I really encourage you guys to try is just take a paper airplane and see what you can get it to do. So like you saw in the video, when we were filming that, it started with me and one other person trying to, just get planes to, turn to the left or turn to the right. And then at the end there, we had everyone who's in the lab making paper airplanes and just trying to do fun things. And so that's really just the big thing. And one of the fun things about engineering is that you can just start trying things and see what happens. And if you just do that and note down what differences you make, you can really demonstrate a lot about how things happen in the real world, even with something as simple as a paper airplane. And so to kind of continue on that note, there are other activities we made to get involved that we don't really have time to run through. And Francis, if you're able to, can you copy and paste these links into the chat for me? And so
Yeah.
one example of that is making straw rockets, where you can take something as simple as just a piece of paper and you make a rocket that you can launch by blowing into a straw. And kind of going along that same vein of, seeing what changes you can make and how it affects the flight, with that activity, you really can go through and, try different nose cones or different fin designs and really see how that impacts how a rocket flies. And we do have another video up on our YouTube channel where we kind of go through a similar video with the forces on the rocket and how rockets fly, where I demonstrate that activity. And finally, the last activity we like to suggest people do is to make your own water bottle rocket. And now that one may not seem very similar to launching a real rocket, but actually one of our projects for one of our introductory classes is to make these bottle rockets and actually do the math on them because the process of forcing water out of that bottle is very similar to the process of a real rocket engine. And so these are just some simple activities that you could really do to get involved with rocketry at home and demonstrate what may seem like complicated concepts in simple ways. And so with that, I think that's all we had. Did anyone have any questions?
Can we give Mike and Francis some reactions, some shout outs and thank yous?
I have a question. What was the hardest NASA challenge you had?
Oh, that's a good question. Is that
So-
Aisha?
No, that's me. Diana.
Diane, okay.
So in terms of the ones I've been around for, I definitely think this year has been a really unique challenge. Because in the past, what we've had to do is like, make a rover or make a drone that comes out of the rocket after it lands. But this year, what we're doing is we have to use data to determine where our rocket is after it lands, but we can't use GPS. And so to do that, we have to find other ways to take measurements of the rocket's velocities and its accelerations. And from that data, kind of work backwards to determine where the rocket is. And part of what makes it so challenging is most of us working on the project and leading the team are aerospace engineers. And really, a lot of what we've ended up doing is closer to being electrical engineering and computer science. And so we don't have a whole lot of experience with it from our classes. So we're really having to go out and learn a bunch of new things to try to complete this challenge.
You have some more questions in the chat there. Let me see if I can take a look at a lot of thank yous and shout outs. How many people are in your club at school?
There are easily over 200 people in our like online messaging thing, but
Okay.
I'd say about like 20 to 40 people. Maybe
Okay.
that's a stretch for this year, but they come in regularly to general meetings and building meetings and things like that. We also have another question. Can you build 5 airplanes in one day? I guess the answer would be it depends on how big the airplane is. But yeah, if you're thinking about doing paper airplanes, absolutely. You can build 20 in a day, depending on how fast your hands work. But big airplanes, not so sure about that one.
Yeah, they move pretty slow. I used to work for Pratt and Whitney, and they built engines, and we only built a handful, a year. So yeah, they move pretty slow, and they were pretty expensive too. I think Jaden had his hand up as well. Jaden, did you have a question? I saw your hand up earlier.
No, that wasn't.
Okay. Aisha says, do you hope to take this to NASA, like using these skills, get a job somewhere like that?
Yeah, actually, I do work at NASA. I'm doing a thing that's called a co-op program where I'm a full-time employee some parts of the year and a student other times of the year, and that'll eventually transition me into a full-time job at NASA, and that is at Marshall Space Flight Center in Huntsville, Alabama. It's really fun. It's a good time.
Yeah, I know I would definitely like to work at NASA or SpaceX or kind of somewhere similar, because the whole building rockets and working on space exploration is really the side of aerospace engineering that I want to get into. And so working at one of those places really is kind of what I want to do.
And what year in school are you both?
We are both juniors.
Okay, so you have another year, and then you'll be off into SpaceX or NASA.
Yep, we both have one more.
Okay.
And then in the chat, I also see someone asked, what experience do you need to join and participate in your club? And we always tell members that you don't need any experience with rocketry or even to be in engineering to join the club. because we have a lot of experienced members and we can teach you everything you need to know. And it's something like I know most of us as we come in don't really have any experience. And through the years, we kind of just learn everything you need to know, both from other club members and from some of our mentors in the rocketry community who have been doing it for a long time.
So you kind of learn as you go.
Yeah, it's very
Do
much
research.
a hands-on process of just, you know, you show up and you can help on things. And as you do that, you really learn what you're doing.
All right, and one last question. What other internships have you had?
So I haven't had much work experience in actual engineering, but I know, Francis, you've done other research with professors too, right?
Yeah, I've done research, and I've also for a summer I was an electrician's apprentice. I wanted to get some,
Electrical.
hard skills with
Mhm.
electronics and things like that. That was really great. But yeah, I've done research over my summers, and that's basically just assisting a professor that works at NC State with a project that they're working on. And yeah, it was a good time.
Excellent. Well, I appreciate you guys coming, and I do want to share one more thing on the screen here before we go, just to give you guys a little bit of appreciation for your efforts today. So on behalf of the Research Triangle Proteges chapter of NSBE Jr, we'd like to present to Michael, as well as to you, Francis, this certificate of appreciation for speaking to us and taking time out voluntarily for our Space Day. So can we all give them a round of applause and thank you for their time? And you came last year and it was excellent. And as always, the students are very excited to hear from you. We do have a couple of high school students who may want to reach out to you. They're in the process of determining where they want to go to school. And I know Jairus has actually been accepted to the Mechanical and Aerospace Department at NC State. So would it be okay if they reach out to you, either of you later if needed? They have more specific questions. Okay.
I can
Yes,
put my email in
certainly.
the chat, actually.
Yeah.
And yeah, I think you have my email. If
I
you
do.
need to
Yep.
send it to them, they can of course reach out and I can try to answer any questions.
Yeah. And if you guys are going out, you know, I know you go to these fields and you shoot your rockets. If that's something that we can come watch from a distance, or a GoPro or something, you know, let us know. We'd love to see it.
Yes, they're open to the public. Absolutely. Please come on out. They're so much fun.
Okay. Excellent. Excellent. We also I want to recognize too, one of our advisors, Mr. Jonathan Winstead. I don't know if he's on or not, but he works for Collins Aerospace. So he may have a couple of.
Dr. Tony.
Hey, thank you, Jonathan. John, do you have any final, you have any encouraging words? I know you are in that industry as well, for any of the students who may be thinking about going into aerospace, into this field.
Well, first, I want to give a big thank you to Mike and Francis for a great job covering the topic in such a short time. It's very complex, but you guys did a good job summarizing what you need to do. For the students who may be interested in going into that field, just make sure you do good in your math and sciences, and and then you just don't get frustrated with the material, because this can be tough at times, but you just got to keep pushing forward. I think you can do it.
Excellent. And as they said, they have to calculate these math problems. They're kind of doing what the Hidden Figures were doing, like they were human computers, but you know, Mike and Francis are doing it, and they're not afraid of the unknown. That's one thing that Dr. Rona McNair told me. I told him I was afraid of the math and the engineering. He said, don't be afraid of the unknown. Like, you're gonna always have to practice on things you don't know about, and that's what makes you a good scientist or engineer. You're not afraid to do it. You can learn stuff, you're a quick learner, and you know how to find people who can help you, and you know what you don't know. Like, you try to stay in your lane a little bit, you know, and if you're gonna mess something up, you wanna do it easy so it doesn't, happen too catastrophically. So just some advice there. And again, thank you guys. You're welcome to stick around. We have a couple of more presentations, and then we're going to go into breakout rooms. So you guys are welcome to stay as long as you like. I know you have plenty of studying to do, but we would love to have you if you want to stick around a little bit.
Awesome. Thank you so much for having us. It is always a pleasure to come talk about rocketry with anyone, because as much as we like building rockets, we like even more having people listen to us talk about building rockets.
Not a problem at all. I'm sure we don't have to wait a whole year to do it again. How about that?
Of course. If you ever need to come back and talk, give a presentation, just let me know. We're always happy to.
All righty. Thank you so much, Mike, and thank you, Francis.
Awesome. Thank you.
All right. Was there another question?
Yes, I have a question for Miss Francis or Mr. Mike here. I was wondering about the math parts going into college. Well, yeah, moving into college, because I'm going to go to the Bond Screener Job Center, and they have a mechatronics program there, and I'd like to, well, I do know for the most part, but I find it helps to hear from people who are currently doing it.
Is that Basil?
Yes, ma'am.
Okay. All right. I'm going to update your name on the thing there. Gotcha.
And so were you asking about kind of math going into a mechatronics program?
Yeah, like what areas should I focus on? Because right now I'm in geometry, and I don't know what that would be.
Calculus?
So that's a very good question, Francis. Can you kind of just, on a broader scale, like kind of tell the students what levels of math they need to get into actually to go into engineering or wrong?
Yeah, I didn't think I would use calculus as much as I do. I use calculus almost every day, and I promise it's fun. It's a great math. It's very good. But I used to hate math. I said, I'm not a math person. I cannot do math. But then I started doing calculus. I'm like, wait a minute, this is actually kind of cool. But yeah, I think the kind of pathway geometry to more advanced algebra, maybe some trigonometry and pre-calculus, and then transitioning into calculus, if you can get to that before college, will put you on a really great path to a science or engineering based undergraduate degree. And yeah, pretty much as much math as you can do will be a great start. And then once you get into a STEM program, they will just keep giving you math, and you will grow and learn more than you ever thought you could.
Even once you start working too.
I would definitely add, for the kind of going from high school to college, there are a lot of us who do come in with already having credit for having taken calculus. But really, I think the important thing out of college or out of high school is to have a solid foundation in algebra. Because I know that I actually tutor both calculus and physics at the library during the week. And so a lot of what I see some people struggle with is not so much that they don't know how to do the calculus, but once they've done the calculus, you got to make sure you're not messing up on those small steps of algebra after you've done that. And like one thing I know, especially with physics, I like to tell people is when you're solving a lot of these problems and you're writing it down on the paper, you do one line of physics and then the rest of the problem is 5 lines of algebra. And so I think that is the really important thing to have coming out of high school, is having a solid foundation in algebra. Because once you have that, you can make it through all the other math.
Okay, thank you. Because I'm not my math teachers. They help, right? But I was a little concerned because like while I'm decent at geometry, I didn't know how much it would help in the fields I am looking into going. Right, but thank you for your answers.
And also, Basil, I can connect you with them offline if you want to continue to connect, because I know that you're interested in mechatronics. And maybe Francis and Mike, do you have any knowledge of how mechatronics will play into this field? Is that something that, okay, students, students should
I'm
be.
actually thinking about getting a graduate degree in mechatronics, so definitely reach out to me.
Awesome. Excellent. Well, wonderful. I don't want to leave this topic, but I know we have some other things to talk about and a couple of other students who I know they're excited. They're probably hoping I'm going to forget that they need to share something, but I'm not going to forget. So, all right. Next, let me get back into the presentation. And again, kudos to Mike and Francis for that excellent information. Now we're going to start exploring Earth. There is so much to learn and explore in Earth. Just a little African American history facts here. As I was, researching to understand, what should we discuss, I ran across Dr. Charles Anderson. He actually worked at North Carolina State University for a while. I did not know that, had not heard of him before, but he did a lot of work in the area of atmospheric science. So he was in, I think it's the Department of Marine, Earth, and Atmospheric Sciences. That's what he was in. And he was a part of the Tuskegee Weather Detachment Unit in the military. So here, again, these links can give you a whole lot more information about him and the work that he did. And basically, he helped to understand, the meteorology and how the atmospheric pressure would affect the pilots of the Tuskegee Airmen. So it was important for them to have this knowledge because they were, flying planes. Next up, just to kind of give us more information on that topic, we're going to have the Voyagers. The Voyagers are members of NSBE Jr. They presented virtually last year at our NSBE National Conference and shared their research on the impact of earthquakes. At the time, they were all in middle school, but some of them have gone on into high school now. So I'm going to get their presentation up and you guys can get ready to present. So this is the impact of and recovery from earthquakes. They did like a 30-page paper, but we had to condense it down to about 10. And they're gonna share some of their research and what they learned here. This is not the full version of it, but for the sake of time, we're just gonna go through some of it. At this time, would you like to introduce yourselves? And Jonathan, you can start us off. And just say your name, school, and grade.
Hello, my name is Jonathan Winstead. I'm a freshman this year and I go to Miss Christian Academy.
Imani.
Hi, my name is Imani Eziogu. I go to school at Odyssey Charter School in Wilmington, Delaware, and I'm in 9th grade.
Okay. I think there's a little echo, so there may be another device in the room with you, Imani, that you may have to mute. Okay. And Daniel?
Hi, my name is Daniel Eziogu, and I go to Odyssey Charter School, and I'm in 8th grade.
All right, and Nana.
Hello, everyone. My name is Nana Dodu. I go to NRCA and I'm a freshman.
Awesome. All right, and Daniel, tell us what earthquakes are.
An earthquake is a sudden shaking of the Earth's surface, usually resulting in great damage. Faults are cracks in the Earth's crust and are the boundaries between tectonic plates. When tension builds up along a fault and then is released, the result is an earthquake. Earthquakes are the number one deadliest natural disaster in the world, causing devastation and crippling of communities and nations. Plate tectonics. This is a theory dealing with the dynamics of the Earth's outer shell. The Earth's outer shell is a lithosphere. It is broken up into plates. These plates move over and under one another. These interactions cause faults in the Earth. Tension around the fault lines result in natural disasters such as earthquakes. Aftershocks happen after the initial earthquake subsides. Aftershocks can occur up to several weeks afterwards.
And Jonathan is going to talk about the Ring of Fire.
Okay. Ring of Fire. The Ring of Fire is the most seismically and volcanically active zone in the world. Areas located along the Ring of Fire are more susceptible to earthquakes than other areas. It is called the Ring of Fire as the volcano earthquake activity area forms a shape of ring, and its length is approximately 25,000 miles long. Some countries that line the Ring of Fire are Chile, Japan, the U.S. West Coast, and Pacific Islands. There are certain areas in the world that are more susceptible to earthquakes than other areas, which are located along the Ring of Fire, which you can see along here, which is the west coast of America, the islands, the Pacific Islands, some parts of South America, and then other parts of Asia.
And for those of you listening, what states are on the Ring of Fire in the United States? Can anyone tell us by looking at this map? What states would be over in here?
California.
California, yep.
I see Florida, I think.
Washington.
Washington, yep. Actually, Florida is not on the Ring of Fire. However, that is a very good observation. We'll talk about that in a minute. And Alaska's up at the top. Jonathan?
Oh, sorry, my mic was on. Can you hear me? Okay. Okay. Different types of natural disasters. The 4 different types of natural disasters that we have here are tornadoes, floods, wildfires, and earthquakes.
Yeah, and also too, Jonathan, we didn't include blizzards or winter weather, but at times it can cause disaster as well. Trees can topple. Sometimes you get tornadoes in the wintertime when you have a winter storm. Anybody?
So especially for those who live along the states that border the Ring of Fire, there are different ways you can prepare. So these steps include securing your space, making a plan to be safe, organizing disaster supplies, and make a plan to minimize your financial hardship. Also, there are some government entities and organizations that help rebuild homes and offer assistance, especially financial aid to those who were struck by earthquakes, as well as structural engineers who work with architects to rebuild communities. If you are around in the event of an earthquake, there are certain tips to keep you safe. So if you're indoors, you should stay inside. You can stand against a wall near the center of the building you're in a doorway, or you can crawl under something heavy like a desk. If you're outside, it's best to stay outdoors and get as far away as you can from buildings.
And Anna?
All right. Structural engineers work with architects to decrease damage to buildings. Structural engineers incorporate special techniques and devices within buildings to make them structurally sound to withstand natural disasters such as earthquakes. A few of these techniques and devices are movement-resisting frames, base isolators, vibration control devices, and seismic isolation.
All righty. And So the team actually did, they pulled together this material. They created their own version of an earthquake. And they used this vibrating shaker device and this box here, which kind of simulated the tectonic plates. And when they put this box in these shapes, they made different shapes of structures, and they put them on top of the box, on top of the vibrating shaker, as you can see here. They were able to recognize which types of shapes were strongest, and these shapes were toothpicks and marshmallows. So they made these different shapes. They had a rhombus, a square, triangular shape. I think there might have been one more. Was it an octagon or hexagon? Hexagon. So team, which of these was the strongest structure?
B.
Yeah, the triangle was.
Yep, triangle was the strongest. So they kind of did a little further testing, and they took data on the different rounds and how much frequency of vibration they cranked up on the shaker, and they pulled all that together. They had to present that in the presentation. So just kind of in conclusion, let me see here. There we go. I think, Jonathan, you were gonna kind of just summarize this.
And yes, for the conclusion, so the best earthquake resistant structure was the triangle, as we talked about earlier. And research shows that dome-shaped buildings based on geodesic structure using rigidness from a triangle element are the strongest against the higher, richer rated rated earthquakes. And dome-shaped buildings are prominent around the world in regions known to have strong earthquakes, such as Japan, California, and South America.
Okay. Any money? Did you get a chance to see where the most recent earthquakes have been?
Yes, so back when we initially presented our presentation, there was an earthquake that occurred in Oklahoma, which isn't along the Ring of Fire. So these earthquakes occurred, I think 2 days ago. And these states are not along the Ring of Fire, so that's why it was kind of seen as weird. But earthquakes occurred in Hope, Kansas, Peach Springs, Arizona, Stanley, Idaho, and Rock, Washington, and they all had a magnitude of 2.5 on the Richter scale. And those are not along the Ring of Fire, but there was one earthquake to compare to those, which took place off the coast of Oregon, that had a 4.0 magnitude on the Richter scale.
Yeah, so someone had mentioned earlier, they mentioned Florida. So I said, hold on to that thought, because we are seeing earthquakes now. More prevalently, we're noticing that earthquakes are happening that are not on the Ring of Fire. There's been an earthquake in Columbia, South Carolina, not too long ago. There's even been one that was felt here in North Carolina. So that's why I asked this team to kind of, revisit this and see what you can find out on what's causing earthquakes that are not on the Ring of Fire. And here are some of the resources. I think, Imani, you used the USGS Earthquake Hazard Program, that website, for your information.
Yeah, I did. And it was able to show me a map of the different earthquakes that had happened in the past day when I looked at those on, I believe, Thursday. And yeah, it gave me all the information I needed.
And there's also an app, which I have. There's probably a couple of free ones, but this one is only $2, where you can get alerts about earthquakes that are happening, and information on what's anticipated. So those are very useful tools. And Nana, did you have a video that you wanted to show?
Yeah, actually, I have a video about like an earthquake 3 years ago in California.
Okay, you can go ahead and show it at this time.
All right. Can y'all see it?
Yes, we see it. And where is this one located in? California, okay.
This one's California, yeah.
All right.
I'm gonna show about 3 to 4 minutes.
So imagine if you were in this house. So this could have been at night. It says it's a 7.1 on the Richter, which is a pretty strong earthquake. It just seems kind of pretty chaotic, doesn't it? She was getting ready to get in the pool. Wow. And this is just video only. There is no sound to it.
This one was like a phone video camera.
Okay. So in the research team, how long do earthquakes typically last? Did you find any typical length of time? Whoa. The cat was getting out of there.
Hello.
And sometimes after the earthquake, there will be, like they said, aftershocks. Weeks, could be up to weeks afterwards. So
The average one lasts from 10 to 30 seconds, but a magnitude 9 one can last over 5 minutes.
wow, that is a long time. Has anyone ever been in an earthquake that's on the call? Anyone ever experienced this?
Yes, I did when I lived in Washington State.
Wow, what was it like?
It was horrible. So I just felt we were living in an apartment and there was a garage underneath. I thought somebody hit the garage, but the building was actually moving. So I just ran and got underneath the kitchen table and waited for it to be over. But yeah, I'll be okay if I never experience it again.
I can imagine. And you know what? I know someone had mentioned Florida earlier. The building that collapsed, I don't know, maybe that could have been a quake and we just don't know it. They never really figured out what caused that condominium to collapse. But the people inside said that they felt the building shaking and saw the wall cracking before it actually caved in.
Yeah, ours just moved from side to side, but everything seemed fine after it was over. So
okay.
But I was in Washington State.
Oh wow! All right. All right. Any questions for the earthquake team? Let's give them a hand and show them some love for their efforts and taking the time to present to us today. Anybody have questions for them? Or thoughts on what you just saw?
I have a question. Just to anybody, just to any of y'all, how much did you know about earthquakes before doing this project?
So I was doing plate tectonics and I chose that to like I wanted that to be my part of the project because that same year I did a project in science class about plate tectonics. So I already knew like a lot about it.
Anybody else?
I knew about the plate tectonics because I did a similar project when I was in school, and I learned about like when the continents split in Pangea. And I also kind of knew about some charities or organizations that would help people rebuild after earthquakes or just natural disasters in general. But besides that, I didn't know much about earthquakes.
Jonathan?
Well, I had never experienced one. I don't think I've ever experienced one, but the most I knew about earthquakes was the scale that they compared them on, and that they're dangerous, I guess.
And Nana?
Like Jonathan said, I've never been in one, but I knew what they were, what they did. I knew about the magnitude about them. That's about it.
All right, and Lauren says, how did you choose to research earthquakes? Did you just find it interesting? And she says, great presentation. You guys remember, how did we decide that this would be the project to work on?
I'm not sure if I remember correctly, but I think maybe Jonathan did a project on it in school maybe, and then he shared that with us and we all wanted to learn more about it and we thought it was interesting, so that's what led us to research it.
Yep. And I would say the team really did in-depth research. We all learned, the coaches, myself and my brother and Miss Sherry and Mr. John, we just kind of learned together. I mean, that's what you do as scientists. You're not afraid to explore the unknown. You go in and you just start studying and learning. And a lot of our early scientists were self-taught. They didn't have the opportunity to go to school and college or have someone teach them. They just learned by reading. Yes, so I did have, here's one final slide that I forgot to show that kind of brings it all together. So fast forward, what the students learn is, here is a geodesic building using the triangles in a dome shape. So this particular house was able to withstand a 7.1 Richter earthquake. So they found that. And then here's a model. Actually, this is one that my brother made in college when he was at South Carolina State University, of an actual natural disaster resistant home. A lot of these are you may find on the coast like this. I think this particular one is in Charleston, South Carolina, but they have a lot of hurricanes. And final resolution is the team found out that you can 3D print disaster resistant homes now. So you can pretty much design your own house and 3D print it if you want to have a home that is earthquake proof, hurricane proof, and in some instances even fireproof. So I thought that was very interesting. All right. Thank you, team. Great job. And everyone really has appreciated you sharing that information. All right, we're going to switch gears now. And it's time for us to go into our breakouts. I won't cover the astronomers right now. We did have a little bit of information on astronomy. So based on the breakout, we can probably do that in this main room. I do want to just mention though, as we talk about space and science and Earth, that Benjamin Banneker I would say, was a forefather in this area, not just for African Americans, but for Americans. He was self-taught, so he did not have a lot of education. He was a mathematician, a surveyor, an early astronomer. He had an almanac that he made. He also predicted an eclipse in 1789. It was very accurate as well. So he was pretty much an early explorer and scientist in the topic that we're discussing today. And he was just pretty much well-versed in so many different areas. He helped design the layout for the city of Washington, D.C. He built the first clock in America. He came out of, he was a free Black person. So slavery was what most African Americans were in at that time. but his parents were slaves and they were freed. I don't remember exactly how they got their freedom, if they purchased it or what the situation was, but he was able to get some exposure to education, but most of his learning was self-taught. And if you're into astronomy, I will share these resources. Astronomy Days just happened. We just missed it. It was virtual. It is always the last weekend in January. So the Raleigh Astronomy Club participates. They did have an event today, but it got canceled. This is a way that you can learn more about astronomy, get a telescope or binoculars where you can see planets and be able to just kind of get more involved and grow your own knowledge and understanding astronomy. That's what scientists do. We get what we need, we figure out how to use it, and we explore it. So I encourage you to do that. And if there's others who are interested in learning more about astronomy, please shoot an email so that we can get on a schedule to follow what's happening in the sky. I think that was an event last night that we missed. And there is one coming up. Let me see. There's an event coming up next week. So I have to email that out. But there's different times throughout the year where there's a major sky event where you can really get a unique view through your telescope or your astronomical binoculars. All right. So let's get into our breakouts. Let me see. I'm just going to give you these quick announcements because when we get through the breakouts, we'll probably be ready to wrap up. If you're interested in tutoring, we do have that going on now up through March the 4th. It's Tuesdays and Thursdays from 5 to 7, Wednesdays from 7 to 8, math, science, language arts, reading, grades K through 12. And as you heard our engineering students tell us, you need to be very good in math. And also, Mr. Winsett mentioned that as well. So if you need to work on those skills and get to the math levels that you would need to go into engineering, we have some help for you. And you're able to come and work on that on these dates and times. If you want to do that, reach out to me and let me know. We have students from North Carolina A&T State University helping us with that. We also have Cortech Robotics team, which is here today, helping us with that. And we might even be able to get Francis and Mike to help us as well. If we like maybe have some rockets for them, maybe they'll come over and help us out as well. There's also some STEM innovators activities coming up. If you want to learn more about diversity in STEM, in wellness and healthcare. So that's coming up on the 11th. Also on the 18th. That's various age groups. I think that is elementary up through high school. And then if you're in 9th through 12th grade, Engineering Tomorrow is offering these workshops for 9th through 12th graders, app development, entrepreneurship, and supply chain and vaccine distribution. So those are some activities that you can participate in. If you want more information on those, let me know. I can send you this registration link. Also, seniors, there's scholarships that you can be applying for. So please make sure that you have given me your GPA verification so you can go in and start applying for the NSBE scholarships in the portal. Don't want to miss out on those. All right, so let's talk about our breakout rooms. If you are interested in going into inner space, this will be deep diving into inner space. That's going to be room 1. And Archie, I'm not sure if you're still on, but Cortex is going to help us with that. And let me go ahead and get these rooms up here on the screen. And what we'll do is give us 15 minutes in these rooms. We'll every 15 minutes go to a different room. We'll try to get in 2 rotations. I don't know if we'll get in 3, but we'll start with 2. And I'll send out a message letting you know when we're going to close out. In the main room, I will just kind of be in the main room for any questions on anything we've discussed. If you want to maybe sit and take some notes and think about what you want to do next, or you want to talk with someone about planning out your college readiness, that's what we'll be doing here in the main room. So let me get these up on the screen real quick here. And set this up so that you can go to these rooms freely. And Cortex, are you on? Are you there, Cortex?
Yeah.
Okay.
Yeah.
All righty, hold on one second here. I think I may have. I need to redo this. All right, so who is going to be leading which room? So Cortex, just kind of let me know who's going to be leading what. So who's going to be, the first room I think is the inner space, which is ocean and under the sea. Who is going to be leading that one?
Yishan and myself are going to be in the ocean one.
Okay.
Yeah. Me and Eric.
Okay. All right, are you doing a second room as well?
Yes, I believe we have robotics in space, and that's Jacob and Shreya.
Okay. All right, so that will be, let's see here. Robotics in space. All right, we'll make that one room 3. And we're gonna have drones in room 2, I believe. If you have a drone and you wanna just kind of share what you know on it, we're all new and learning. So drone technology is something that students should be getting comfortable with and learning and exploring, because you may actually have to work in an area where you need to program or use a drone. So that will be room 2. So room 1 is inner space, which is the ocean. Room 2 is going to be intro to drones. Room 3 is going to be robotics in outer space. And the main room, which we were in now, is kind of like the STEM lounge, where you can just come and discuss whatever you need to, study, ideate, create. All right, so these rooms are now open. And you should be able to go to these rooms on your own. Does everybody see the rooms? And if you're having trouble getting there, I can put you in the room. So go ahead to your room, and this first one, we're gonna go until 12:40. We'll go to 12:40 with this first room. And I'll send out a broadcast message when it's time to rotate to your next room. And we'll do 2 rotations. You can choose 2 different things, 15 minutes each. So go ahead and identify the room that you want to go to.
Miss Tony, sorry. I'm a little confused on which room I should go into.
Okay, let me see. Why don't you go to robotics? I think that might connect you to mechatronics a little bit. That'd be a good exposure for you.
Okay, ma'am. Thank you.
Okay. All righty. Did everybody get to a room? Let's see. Jaden, I didn't see you go to one. Are you going to stay in here?
I don't know what to do.
You don't know yet? Why don't you check out the ocean in room 1? All right. All right, everybody should be where they need to be now. John, I'm gonna make a little round. Can you stay in this room?
Yes. I
Okay.
will.
If students have questions about what they learned today, you know, what are they thinking about? Maybe some are in high school, maybe some are elementary, middle school. This is kind of what this is kind of like going to see the counselor.
I got you. I'm good.
Yep. Point them in the right direction.
Sure, I got it.
Thank you.
Recording in progress.
Ms. McFarland. So today we're going to be talking a little bit about the ocean or inner space. Right before we start, just to introduce myself, and Ishan, if you could introduce yourself after me.
We're brand spanking new.
Are you located at a school or?
No, we're a community chapter. So
Gotcha.
we're sponsored by the Links